Hello everyone, this is Vashishta from Aerobase section. Today I am going to explain about structural analysis approach for the generation of structured residual for aircraft FDA, which is a tech talk topic. Coming to the introduction, research on fault detection and isolation (FDI) has traditionally been an important topic in avionics. Flight control systems for higher performance aircraft are required to cope with the detection and identification of failures of different components, such as sensors, actuators, and flight computers. The importance of a correct and prompt FDI cannot be underestimated since undetected and or misclassified faults may lead to unstable and unrecoverable flight conditions. Typically, FDI methods are based on the comparison between the behavior of the plant and the response of mathematical model. The main conceptual approaches are currently pursued. The first approach is based on dynamic observers, while the second approach is based on the use of non-linear analytical redundancy relations (ARRs). The effort described in the paper is related to ARR methodology and analytical redundancy relations. Particularly in ARR-based FDAs, the model equations are manipulated to derive diagnostic signals, which are which are based only on measurable variables. Ideally, ARRs are zero in fault-free conditions and are different from zero after the occurrence of failure. Each ARR is characterized by its binary fault signature indicating the set of faults to which the ARR is sensitive. The need for isolating different faults requires a simultaneous equation evaluation of multiple ARRs called structured residual subset. To signature define the binary signature matrix, those ARRs should be designed such that the different faults have been different binary codes in the signature matrix, thus allowing the ambiguous isolation of the fault. Faults in nonlinear aircraft modeling, fault modeling. In this work, the failure of actuator and sensors are considered. The faults are modeled as independent additive signals, F as shown in figure. The signals excite physical signals that are not directly available but are known through their measurements provided by the sensors line. The vector of internal variable is defined as x, while the vector of sensor measurements is defined as y. Similarly, system input signals MI represents the physical signal delivered by the actuators, while the actuator command signals are named UI. Additive faults acting on sensors and actuators. Aircraft modeling. Consistency relations were derived from the nonlinear mathematical model of the semi-scale YF-22 research aircraft. The model equations were derived following the approach outlined, while the modeling parameters were computed through a non-linear parameter identification (PID) analysis performance based on several collection of flight data. As described and used in the same purpose, the following aircraft dynamic is described by the following differential equations. Given R1 is equal to V minus Fx cos alpha cos beta plus Fi sin beta plus Fz sin alpha cos beta by M equal to 0. And these are some of the relationships and the equations regarding differential equations regarding the PDA. Structural analysis for FDA. A structural model of system consisting of a set of relations R is equal to FR1, R2, RMG, which depends on a set of variables Z is equal to FZI, Z2. Analytically, the relationships are expressed as follows, where RJ represents a dynamic or static, linear or nonlinear equations. In this work, the relation set R is continued of the set of 25 relations, while the set Z is the union of all known as variable Z, U of M, X, Y, F. Usually, the set relation R is not directly usable for real-time computation of residual signals because this may depend on unmeasurable variables. However, by appropriately combining the relations in H, R, it is possible to derive special subsets of relationship where all known variables X and M are eliminated so that these relations depend only on measurable input-output variables, Ui by I. This input-output relationship will be referred to as AAR. In order to generate AARs with the desired quality sensitivity, it is more important to investigate the possibility of solving for unknown variable from the set of constraints, which is the concept of calculability. Calculability. The definition of calculability was motivated by the practical need for mathematical solving the constraint Rj in function of dependent variables at I. The structural model associated with the relations set R and their calculability property were represented using the following constraint structural matrix. Sc of Ij is equal to Rj depends on Zi and Zi is not calculable from Rj. Application of FDI scheme to the mathematical model of WVU YF2022 aircraft. Structural analysis results. The starting point of application of the FDI scheme to the YF2020 is the computation of SC matrix that relates the 25 relations to the unknown and known variables. The SC matrix of YF2022 is due to space constraint only the dependence variable of uy x uy. As we can see in this, the x coordinates and f coordinates with the constraint structural matrix for the Y22 aircraft has been shown with the different various velocities. And another table regarding performance comparison for the difference cost functions. Based on SC matrix, the algorithm of automatic generation of ARRs were executed. The algorithm explains all the possible ways of eliminating variables. The algorithm for the calculation of MIARRs was run for each cost function separately. The number of ARRs indicates the number of ARRs continues the not isable faults. Coming to the conclusions, the paper represents the results of an effort towards defining an automated procedure for the design of subset of structured ARR suitable for real-time application of FDI schemes. Practical implementation should have been considered in the design methodology through the introduction of ranking for residual selection priority, particularly to the selection of different performance indices that it was possible to select structural residual subsets with high detection capabilities along the desirable robustness properties. The methodology was validated using a detailed mathematical model of semi-scale remotely controlled YF 2022 research aircraft. The analysis shows the minimizing the total number of derivatives to be calculated in the residual provided the best overall performance in the sense that minimization of a derivative contribution was allowed, maintaining an acceptable computational complexity along the significant fault. So this is all my explanation. Thank you.